for today, my topic is integrating Arcadia-Capella with MBSE along STPA for early safe stage analysis in railway system. Okay, so what will be there in the agenda for today? Introductions, problem statement, the method, along with STPA, value propositions and conclusion, and references. A brief about myself. My name is Patwardhan. I have total 10 years of experience in automotive industry. I have completed my BTech from BITS Pilani, and I have been leading automotive projects at BlueKei Solutions from past 2 years. Okay, this is a slight brief about the company, what we work for. So basically at BlueKei Solutions, we are digital engineering partners for systems engineering activities. What do? We empower decision makers to transform their business digitally by managing their cost, time, and quality using the MBSE methods, processes, tools, and technologies while minimal rework for the clients. So we have served almost 15 plus Fortune 500 companies, 25 industry experts, 85% of repeat customers, which we could achieve. We have offerings basically in three categories. One is during the competency development, one is the knowledge consulting, and one is project execution perspective. We have worked in several industries: aerospace, automotive, satellite manufacturing, medtech, and now railways as well. So before I move further, due to bandwidth related concerns, I may have to switch off my camera so that it doesn't affect the quality. Yeah. Okay, for today, my problem statement is on the railway. This statistics which you see is about the Indian railway market, which I have considered. In the past 5 years, we have witnessed almost 350 or more than 350 lives have been lost, and 1,000 plus serious injuries have been occurred. This has been a statistic which is from 2019 to 2024. And you see the 300 plus crore loss of operational property as well as compensation. So it's a huge amount that has gone into these accidents which have caused over the period of 5 years. Now, here, the major concerns which were observed during these 5 years was typically due to signaling errors or derailment errors, which were quite dominant. Again, it's a slow safety tech development in case of railways, which is not that fasterly adopted at that rate. So this could be one of the causes over the years that is seen. And it's not only random failures, but they are rooted systematic failures which have led to these causes. So of this, one of the case which was there was noted on 2nd of June 2023. This was the case of a Coromandel Express accident, and where almost 276 deaths have occurred. And the reason being for this issue is the electronic interlocking defect due to signaling error. This was the case. Now, if you see on the right side, you see there are at this station called Bahanaga Bazar station at the Balasore district, you see there are 4 lines. These 4 lines are 2 down lines and 2 main up lines. So one is the main line, one is the loop line. And on the loop line, there are the goods train, and the main lines consists of 2 trains traveling parallelly. One going towards Bangalore and one is coming towards Chennai. So that is the Coromandel Express, which I'm talking about, this red train. Okay. So at the point where you see that 17AB point written, at this point, the signal, the train got diverted toward goods train, which was standing here, containing heavy iron rods. So the train Coromandel Express was coming at a speed of 128 kilometers, and it banged into the goods train. And the impact was so heavy that the train which was simultaneously passing, this is called as the HARA Express, was traveling in the opposite direction. The last 2 bogies of this Coromandel Express happened to jump or happened to derail the other train because of that. So these 3 trains collided and had a huge impact. Almost 1,000 plus serious injuries were observed. And the systems involved here are the sensing system, the point machines, the signaling systems, the interlocking system at the station, controlled by the station master. So we'll go further. Okay, what was the objective of taking this? To deliver a safe and reliable interlocking system by implementing an MBSE Arcadia approach using a safety assessment like STPA while continuously iterating unsafe control actions for human errors or interlocking faults at a logical layer. Okay, so this is a typical MBSE Arcadia workflow. These are the different perspectives of Arcadia: operational analysis, system need analysis, conceptual architecture, and the physical architecture, which we say. At operational analysis, we do the objective of this layer is to identify stakeholders and accomplish its actions and relations with it. System analysis is more about the system and its stakeholders. And at the logical layer, we see how the system will fulfill the expectation. Similarly, we have followed the same Arcadia approach to do the problem statement. So this is the first layer, which is the operational analysis layer, where I just identified who are my entities and what are the operational capabilities for the railways. So like enable safe train operation, coordinate train dispatch and scheduling, route management, provide real-time updates, and the relation with your entities has been established here. And at a high level, this is the architecture diagram, which we call as the OAB diagram, where we give the communication or relations between the different entities and how they are interacting with each other. Then we come to the system analysis layer. Here at the high level, we identify what is my system of interest. So my system of interest at this level is signals and communication system. I don't know what is the failure inside it yet. So these are my high level functions, which are seen in the green boxes out here, and the lines which you say, or the interactions between them, are shown with a green line and a blue line. These are nothing called as a functional exchanges. So how the communication flow is going to happen, that has been depicted here by the functional chain approaching a junction scenario. So before I go into the actual architecture at the logical level, I have what is an interlocking system, what is the function of an interlocking system, and who they coordinate with. So in interlocking system is present at the station, and it has three critical things which it interacts with. One is at the wayside equipment. When we say wayside equipment, it consists of the detection of train track sensing system, then point control systems, and a master room where this coordination occurs. Who is going to give you the request to the main line or the loop? Now, at the logical layer, I am describing how the system will be designed for the user expectation. What would be my logical components? What would be my function and functional exchanges? So here I've just depicted at the interlocking, I have certain functions available. Some of the functions are route checking, track verification, or the lock routing. So these are the functions which are depicted here in the green, which you see. Okay. And similarly, you have some functional exchanges which are there. So maybe vacant route signal, visual green alert. If you see this, like a visual green alert and a vacant signal, which is given here. These are certain functional exchanges. So many other function exchanges are also available, which you can see in this diagram. And other logical components which it interact to is in the wayside field equipment. One is the signal controller, track circuit sensing system. In the location side, location box, you have a point machine system, which monitors the physical blades to divert the route from one direct to the loop line or to the main line. So before I go further, I happen to ask myself a question. Is this architecture really safe? Is there anything I'm missing? Are there any functional exchanges which I've missed? This has brought me as this single source of truth for my further step of analysis. Now, STPA, this is the safety assessment or analysis which I will be using. So this is Systems-Theoretic Process Analysis, which was developed by MIT Boston. Now, when we say safety analysis, there are several methods, which are the classical, typical safety approaches across various industries, be it HARA, FHA, poultry, FMEA. Many other are there. But here, why we have taken this? These have a certain limitations. What are the limitations? I would say they are more component centric. They are cause linear effect chains. human interactions and the system or the other system failures on your system are not that effectively evolved. So hence we leverage STPA for this. So STPA is defines each problem as a control structure and the unsafe control actions at each of this. That's the beauty of STPA over the other typical methods, and those are purely component centric and hazard based approaches typically. Okay, and here this has gone or gained more expertise because it has been very well applied to software defined vehicles in the standard 21488. If you all are from the automotive background, then it is the first step. Instead of HARA, they are applying STPA because they are looking into SDVs or cyber physical systems in future. So this type of architecture analysis is well suited for those where software human interactions are easily evolved or any cyber critical systems are evolved, that those can be easily mitigated with this kind of early safety analysis. So as I said, it works in a controller and process format. One is the control activity and one is the feedback loop. Now there are 4 steps of doing it. 4 steps are purpose of analysis, hierarchical modeling, UCAs, which is called as unsafe control action, and then the loss scenarios. At the first step, we identify accidents and hazards, then construct a planned control model, then identify unsafe control action, identify the factors and flaws behind them. And this is applicable for all complex critical systems, and typically all industries can apply this very easily. So the benefit of STPA is not just the component errors, but integration, software errors, and human errors are under consideration. So that's the beauty of using STPA. Okay. So now in my case study, how have I leveraged STPA? So as I said, it has 4 steps. The first step is the purpose of analysis. So in the purpose of analysis, to start or begin with this, I have to take my logical architecture as the basis of it. On the logical architecture, I start with the step number 1 of the purpose of analysis is to identify my stakeholders and stakes who might get affected by it. For example, loco pilot, what is at stake for him? His life is at stake. For example, rolling stock, what is at stake for it? Infrastructure is at stake. So similarly, I identified my stakes and stakeholders. Then I go off with the losses. So losses or accidents that could be caused because of it. So loss to life, operational damage, infrastructure damage, misroutement or misalignment. These are typical losses that could occur. Then from the losses, I start defining my hazards. So what kind of hazard may lead to my loss eventually? So the hazards can be a track circuit failure, no extra safe fail safe mechanism like Kavach or ATPs, wrong or misleading signal alterations, train proceeding in the main line, which is the case of the Coromandel Express. These kind of hazards may lead to these kinds of losses. So they're interrelated. You can see there is a bidirectional arrow here, which says that they are interrelated to each other. So hazards are related to the losses. And when you go to the next step, which is called as the system constraint. So system constraints are nothing but how would have you look into your architecture to not cause these hazards. So the routes must be exclusive. Interlocking logic must prevent unsafe movements. Interlocking recheck and validation has to be done in order to not give a wrong signal. Signal aspects at the signal controller should be accurate. So these are the system constraints which has to be taken into consideration to mitigate or not cause such kinds of hazards. Okay, and this all has a bidirectional traceability. You see that each of this is linked to each of the components here. So this is called from the model item, stakeholders, stakes, losses, hazards, and constraints. This is how we arrive at the first step. Now with this, we start the second step. This step becomes the basis for my second step of analysis. And the beauty of using it in this tool or as a plugin is it's not isolated. So means the architecture is not in some separate tool and you're not using a separate analysis tool or an Excel based document to do this analysis. So they are interrelated in some some sense. And tomorrow, if any changes or you want to keep on adding your hazards and losses, you can add and have a traceability link to each other. That's the beauty of it. So the second step is to model the control plant. So before modeling the control plant, again, you have to check who are they interacting with. What are my systems or components involved in each other? Interlocking system, point machine, signal controller, rolling stock, track sensing circuits, station control room, loco pilots, maintenance staff. Any of this can cause error. So I'm considering at this problem only these two in the loop. So how are they interacting? What are the control actions? What is the feedback path? So here you can see that the interlocking system and the point machine 17AB, where was the actual fault. So there is a feedback loop which had given a wrong signal. So this has been taken into consideration and modeled as a control structure. So what may cause this unsafe? What are the critical points which were missed? This has to be asked for each of this loop. And we have modeled in all the other systems altogether with it. But for the purpose of demo, we are going to look into this control structure only. So when I say unsafe control actions, what do you mean by unsafe control actions? When you provide any control input, which we just saw, the feedback loop or the control activity, which we just saw in the previous diagram, they can rendered or they can be unsafe due to 4 criteria. When you are providing it, it will cause an hazard. By not providing it, it will cause an hazard. Wrongly providing it might cause an hazard, or providing it too soon or too late might cause an hazard. So all these 4 probabilities can occur to a particular control loop in action. Okay, so that's where we are trying to analyze what will happen between that in all possible scenarios. And is my constraints getting violated? What hazards will get linked to it, or which hazard is going to occur because of the violated constraints on the unsafe control action? So what could be not providing? Point machine fails to move when recommended, detects normal when it is physically reversed, which is the actual case, and interlocking doesn't detect the location box. That could be another severe case. And then point machine moves when it's under maintenance. That could be also a hazardous case. So these all possible things may lead to some hazards like death or routing getting into the main line or the loop line. That could be the cases that might occur and the constraints being violated. So now how do you mitigate this? So after doing this, you come up with a 4th step for the loss scenarios. So before going to the loss scenario, so these are my loss scenarios when I tried to analyze my system at that level. What happened between them? So this was the loss scenario 1. This is the loss scenario 2 and loss scenario 3. There was some exchange or there was tampering at the point machine box. The point machine box, when it was tampered, it had changed the label normal to reverse. It gave a wrong signal, and interface interlocking system has interpreted it as a wrong signal. So when there was a request on the main line for interlocking, the polling request was granted. The main line was given clear signal. The routing request was approved. Verification was given passed. And the green signal was given as a visual alert for the loco pilot. And he, at 128 kilometers, ran into the loops line. That's how the incident had occurred. So how could that be have mitigated? If possibly mitigated, how could that be mitigated? There could be possible tamper detection circuits that can be installed, authorization for maintenance to complete the maintenance before the GN request or the route request is given, double safe verification at this level, whether if this person is lying, the point machine is lying, is there any other sensor who is giving the correct feedback? So these things could have possibly saved the accident. Okay, so then I did a detailed analysis by adding a tamper switch, a WSR wiring, a dual sensor, and an axle counter to act as a double failsafe mechanism. So proceed to track, request a maintenance SMS request. He will open the box, do the maintenance, then the the station master should be allowed for the interlocking request. Else it should be blocked. If the GN request is granted, then he will ask for the polling for the track circuit every 500 millisecond. If the track is clear, it will give the track signal clear. It will simultaneously check for, not simultaneously, but in certain seconds, it will check for loop occupancy status. It will check if tamper switch is normal or it is not, detected normal or not. Then it will give a routing request. It will check for the other axle counters and dual machine point machine status. Okay. Then it will check whether tamper switch is again normal or not. It will check if wiring resistance is given granted yes or not. And finally, if the verification is passed, then only the green signal shall be given to the signal controller, and then the signal controller can give it to the rolling stock. So this is one of the scenario. Anywhere this can occur as an error. So those many loops will get involved or added as more functions. At this, we have just considered one and possible solutions towards it. So finally, when I say this, so logical development forms the basis of STPA, and the STPA analysis helps you refine your logical architecture. So model upgrades, mitigation requirements, newer functions, function exchanges, and components. These are the upgrades which has happened here. If you see those highlighted boxes are the new additions and the requirements which are linked to each other with the functional exchanges along with them. So tools, methods, process, this will help you build a better architecture. That's something which I want to say. And what's the overview? So we started with the operational analysis, system analysis. We did the logical architecture, did the safety assessment on it, and then finally arrived at the fail-safe architecture. What was the value proposition of this? It helps in the early safety integration, a unified approach, gaining a little regulatory confidence, risk reduction, and scalability across similar kinds of products. That could be a value proposition for such kinds of a system. What's the conclusion? So, what did we see? We see that are certain problems in the railway application, especially the signaling challenges. The design is complex, it's heavy cost involved, human safety is at risk, operating economics is at risk, and many other possibilities come along with this. So that's the reason we had taken this problem. Then we used MBSE, SE, and STPA to come up with safety flaws. Then we have had design changes, safety requirements derived from it, and a better architecture, which may lead to further improvement like Kavach. So this is a Kavach unit. Probably such more things can bring up to a more modern railway system architecture with Kavach units for better safety methods. So what is the final takeaway with the audience? It's a state-of-art applications for all, specifically to railway applications, linear proactive analysis, I would say, reusability and scalability across similar functions, products. And yeah, I'm done. So thank you. Any questions? And these are the references which I've taken this from for myself.
Great. Thanks a lot, Ketaki. It's a very interesting presentation. Again, it's interesting to see examples of STPA and safety analysis with MBSE and Capella. Let's start right away, if you don't mind. So first question. The question is, as you said, STPA shines in identifying hazards from socio-technical systems, not only failures. But in my understanding of MBSE, it models components and systems. Then what is the added value of STPA with MBSE? Have you compared the scenarios generated with STPA compared to more traditional methods such as FHA and so on?
Okay. To answer this question, I'm not saying that it is going to replace FHA or the traditional methods. As I said, this is more of an early safety analysis. It is just to identify the interactions, or we say the control loops between when we model it as a plant and a control, We are trying to identify what failure might occur due to human errors, but these might not that effectively be used or identified in doing FMEAs or traditional methods, because they focus mainly on malfunctions. I'm not saying that it's going to replace it, but it is more effectively able to capture those scenarios which other system might cause a false on your system because of identifying unsafe control actions in form of feedback loops and the control activity. That's my answer to this. So
Yeah.
the STPA plugin is available at the website, which is there on the Arcadia website. You can see that it is applicable for 6.1 version and needs to be pre-installed, and it's open source again. So you have to first develop the model and then uh, download this plugin and put it in the Dropit and stitch it to your model. So the control loop structure is linked to your architectural element. It's not like the architecture is going somewhere and the link is somewhere. No. So they are linked together, and it is used on the with the viewpoint, STPA viewpoint. That's correct. So we have applied it at the LA layer specifically.
Okay. Great. Thank you. So then next question by Rajat. Would STPA be needed in conjunction with a HA or A?
HARA.
HARA, I don't know how you pronounce this exactly, but yeah,
Okay.
HARA, yeah.
Okay. So if it's I would have a two answers to this. If it's a software defined or a cyber critical system, I would say that STPA will have a little leverage to identify errors more effectively. HARA, though, can be used for no component based systems. I'm not saying that it's not that the other systems will not effectively take out errors. It's just that STPA has this little edge to capture those interactions during the software defined vehicles in perspective. Yeah.
Last question. For now, STPA excels at capturing human interaction errors. In a cyber context, how can we model an operator's behavior within MBSE when they are induced into error by a compromised interface, information integrity attack, for example? Effectively distinguishing this scenario from standard human error or lack of training.
I don't have an immediate answer to this, but maybe a cybersecurity add-on called as Dark can support this addition to STP.
And there was one question that was added. Yeah, how was the process you used to integrate,
Integrate.
iterate,
I think it's integrate.
integrate with the stakeholders and capture loss and validate safety recommendations?
Okay. So for that purpose, see, STPA can be applied at all layers. For at the logical layers, I just identify who would be my immediate stakeholders, like the pilot, the loco pilot was there. Then if passengers are involved, but passengers are not going to directly be involved in the interlocking case, right? So the first step of doing the purpose of analysis to identify the stakes and stakeholders relevant to your level of architecture. So STPA, I leveraged it at logical layer. So at the logical layer for the interlocking system, what would be my entities involved? That is the first step. What would be at stake for them, and then that forms the basis for doing the losses and the violation of constraints on basis of that. Okay, so I hope. I mean, logical architecture is the basis for my STPA in this case.
MBSE architecture is more or less based on component level. How hard is it to modify already existing MBSE architecture to get there all non-component related stakes in order to use STPA in full complex scale?
NBSC architecture is more or less based on component level. How hard it is to modify existing. See, STPA is an iterative process. You have to keep on adding, or you can refine it to an extent till you are satisfied as a valid answer. So it's not you can apply from the OA, SA, LA, PA, all the layers you can apply, and then you can still keep on applying till you find whether you have actually come out or mitigated some requirements as safety requirements. Okay, so it's not only at component level we say, You can apply STPA even at functional analysis, I mean to say the system analysis layer and the operational layer also. But I applied it at LA, keeping that my system functions are very much evolved at this stage. And when I apply it at logical level, it might be relatively late, as my definition goes as early analysis. So I thought that logical architecture is a sweet spot for myself to leverage this case study. So that's the answer.
Thank you again, Ketaki, for your time.